Okay, so we begin. We have modeling with equations. So we want to take everything we know about equations from chapter 1, and we want to start to apply it in order to model real-life situations, which is obviously where mathematics is more powerful. And so these are the really topics that we're going to cover, and tougher problems, problems I'm not necessarily going to model for. You just got to kind of figure it out. And some of you will figure it out, some of you won't. That'll just be the way it goes. So consecutive numbers. So it really should say consecutive integers, I suppose. But the fact is that we have these consecutive numbers, and if I say that you have x is one number, what would be the number after? What expression would I use to model the number after it? X plus 1, and then x plus 2, so on and so forth, okay? But how would I model, evens? What would I do to x to make it even? Okay, so x plus 2, but if x was 1, then that expression would be equal to 3. So unfortunately, adding 2 and 4 does not give me 2x. Double it. Very good. So if I multiply any integer by 2, it will for sure be even, won't it? Okay? And then what would the one after that be? 2x plus 2, because you got to skip 1, right? And 2x plus 4, and so on and so forth. So what about consecutive odds? What would you do to make something odd? 2x minus 1 or plus 1, sure, yep. So if you add 1 to an even, it's going to be odd. And then I say 2x plus 3 and 2x plus 5, so on and so forth. Okay. So, we got example 1. It says find 4 consecutive odd integers whose sum is 80. And if you remember, we had a speaker from Riverland a few years ago at graduation. He said, what are the 4 consecutive integers that sum to 120? And the math people were like, well, 27, 29, 31, 33. Boom! Done. Now, the fact is that we could teach you how to do that, but that's not the point, folks. The point is to model. So on your test and on your homework, you must write the equation. You're like, well, if I can figure it out without an equation. Well, trust me, I can come up with a problem that you can't figure out. Okay? So just understand that we are trying to write 4 consecutive odd integers. That sum to 80. What does it mean to sum to 80? They add to 80. So if I add up all those odd integers, they make 80. So that's important to model it mathematically. You get good at modeling things mathematically, you make 6 figures right out of college, okay? It's called operations research. Get into the field, make tons of money. Be really good, okay? 2x plus 2x plus 2x plus 2x. So you got 8x, and 1, 3, 5, and 7. Okay. Now we solve that equation. We have 8x is equal to 64, so x is 8. I'm done, right? No, why? Plug in what? 8 to what? Into x. So we have 4 odd integers. Those are what we are trying to find. So if you plug in 8, 2 times 8 is 16 plus 1 is 17. And once we know 1, obviously the others will follow. Quite simple. But those are my odd integers. So understand what I'm looking for. And this is what I will require on the test. Model it with an equation, solve the equation, come up with a solution that matches the context of the problem. Are we clear? So let's try one where I haven't given you the actual model yet and see if you can come up with it. Find 2 consecutive squares whose sum is 613. How would I write an expression for 2 consecutive squares? Okay, so 2 consecutive squares would say be 9 and 16, which is 3 squared and 4 squared, correct? So what Jens has done there is he said that is x squared, and then we are going to take 1 more than x and square that. See it? So therefore, we have x squared plus the quantity x plus 1 squared is equal to 613. Is there any confusion about how those pieces were arrived to? Because some people had questions last hour, and that's fine. So Everybody's okay with that? Way to go. All right, so x squared plus x squared plus 1 is equal to then 613. Okay. Can we all agree that we're done with that? Can we all say we'll never make that mistake again in our lives? Okay. Guys, I don't want to ever see that again. Okay. Boil it out. So I have 2x squared plus 2x, and I will subtract over the 613 because I don't know the 613 product property, but I do know the zero product property. So the number 0, great. Mr. Stevie is getting excited. I'm sorry, Mr. Nemec is getting excited. They're always together during track, so it's just kind of, yeah, well, you know. If you're a thrower, your last name's C. That's all I care. I don't know. Are you? Okay, all right, so now let's factor this. We need two numbers that multiply to 306 that add to positive 1. So they're going to be pretty close together, right? I mean, if they add to positive 1, then it's going to be like negative 15 and positive 16 or something like that, right? So what do you multiply by itself to get a number close to 306? Well, if you're really good with your squares, you know 17 times 17 is 289, and that 18 times 18 is 324. Good, nice. So it looks like 17 and 18 will work quite well, wouldn't it? So we'll go 17 will be the minus, huh? And then the 18 will be the plus. Sweet. So x is negative 18 and 17. Done? No, why? Find two consecutive squares, it says. And so we have this x squared and x plus 1 squared. So let's start by plugging in the 17. What's 17 squared? I just said it. 289. And what is 17 plus 1 is 18. 18 squared is 324. Do you think it'll work if we plug in the negative? Let's try. Negative 18 squared is 324. And then negative 18 plus 1 is squared is. And thus, our lesson, math is always smarter than we are. We bow to mathematics. It's like, it just always works out. So, we got it. What do you think of that? You like that? Okay, flip it over. Yeah. Well, the point is that either one would give you the correct solution, 289 and 324. That's the idea. Okay. I don't like to use the word always. Generally speaking. Okay, how about this one? Let's go back to geometry, right? You guys love geometry. Raise your hand if you loved geometry. You're like, yeah, that's right, my wheelhouse. Like, I love proofs. Please, Mr. Teacher, give me a harder proof. Yeah, yeah, love it. But hey, this is the safe room. Like, you should feel safe to say I truly love mathematics, right? You guys are all getting at a stage where you can be labeled as math nerds, right? Like, once you get to calculus, you're automatically math nerds. That's all there is to it. Okay, so a rectangular garden has a perimeter of 288 feet. If the length is 4 more than twice the width, what are the dimensions of the garden? What should I do first? Draw a rectangular garden. What should I label? Length and width. Now, I could really use, like, yeah, and like an intelligent statement involving an equation. Ooh, wow. On cue. So he says length is, that's equal sign, 4 more than is plus sign, twice the width. Nice. Like to take English and model it mathematically. Awesome. So then what about another equation? Because I need something else. I need something for 2L plus 2W is equal to your perimeter. Or 2 times the length, which is 4 plus 2W, plus 2W is equal to the perimeter, which is 288. So notice that we had two variables, length and width. That will require two equations. We have one for perimeter, we have one for length is equal to 4 plus 2W. Now we can solve it. 8 plus 4W plus 2W is 288. Or 8 plus 6W is 288. Or 6W is 280. And W is then 46 and 2/3. Have I answered the question? The question asks, what are the dimensions? So I have width is equal to 46 and 2/3, but I need length. How will I do that? Plug it back in. 2 times 46 and 2/3 gives me 93 and 1/3. And add 4, 97 and 1/3 feet. Now I've answered the question. It's nicely laid out. It's got a picture, it's got a formula, it's got an answer. Teacher can see the work, you know. If you double 46 and 2/3, you get 93 and 1/3. Then when you add the 4, you get. Okay, let's get to a new type of problem. And this is one that you guys haven't seen before, but you will see again this year, and you will see in the future as well in calculus. A box with a square base and no top is to be made from a square piece of cardboard by cutting 4-inch squares from each corner and folding up the sides as shown in the figure. Okay, there's no figure. The box is to hold 100 cubic inches. How big a piece of cardboard is needed? So here's what I have. You can see that I have a sheet of paper. And what I did is, it's not a square, but I really have a perfect square. I just cut out these squares on the corners. See that? What I decided to do is I folded up the sides, like so, and now it is a box with an open top, right? You can use like some duct tape and stuff, but you know, it could be a container that could actually hold something, right? So that's what we're trying to do. So I'm going to start by drawing this piece of cardboard. Now we'll see where you guys take this. What should I write? There's two things I can write that should jump out to us right away. What can I include in my diagram? Yeah, I cut out these little squares, right? 16 square inches, right? So we'll just label it 4 by 4. Awesome. Something else. Last one was about perimeter. This one's about volume. Awesome. Volume is equal to what? Length times width times height. And I know the volume. The volume is 100. Is equal to length. Ah, dang it. That I don't know. But I do know that the original piece of cardboard is an unknown dimension that I call x. And I do know that it's a square piece of cardboard, so it's x by x, isn't it? So you tell me, when I actually cut off the corners, what is an expression for the new actual width or length of the box? Is it going to be longer than x or shorter than x? Shorter than x. By how much? 8. It'll be 4 off of one end and 4 off of another. So the length will be x minus 8. And the width will be x minus 8 as well. And the height yeah, 4. When we fold it up, it'll have a height of 4, right? So we cut 4 off of each corner. When you fold it up, it'll be 4. Whoa. And so I get 100 is equal to 4 times the quantity, x minus 8 squared. Now understand, we just did a unit on solving these type of equations. So you should be excellent at doing this. What do I do? So 25 is equal to x minus 8 quantity squared. Now what? Plus or minus 5, right, is equal to x minus 8. So x is equal to 8 plus or minus 5. So what are my two solutions? 13 and 3. Do they both work? Does just one work? Tell me. Check. So check. What do I got? What are you thinking? Somebody laugh. Do they both work? Let's check. 13. If you take 13, you subtract 4 off of each side. That'll leave 13 minus 4, which will give you 5. If this was 3, you would subtract 4 and 4 and get negative 5. Does that work? Can you have a dimension of negative 5? No. But understand, mathematics doesn't quite know that. Math doesn't understand that you can't have negative dimensions, right? And that's what makes math cool and better than us. So we'll say it's 13 inches by 13 inches should be our original piece of cardboard. The 3 does not work because it gives you negative dimensions, which is sweet to think about, but your head hurts after a while. So, all right. Last problem for the day. A right triangle has a hypotenuse. Isn't that a great word? Hypotenuse. Of length 12.5 inches. 12.5. 1. Thank you. I practiced. Thank you. Thank you. Oh, all right. You do have a great triangle. That's really good. You have talent. All right. One leg is 8.5 inches longer than the other. What is the area of the triangle, excuse me. You tell me, what should I write down? I like both those things. I'm going to use both of them, but I need something else. Awesome. So if I want to find the area, I have to find the lengths. If I want to find the lengths, I have to use the Pythagorean Theorem. Thank you, Pythagoras. Thank you, Pythagoras. You are wonderful. We love you. Been dead a long time, but we still remember you, dude. Just in case you're curious, many cultures actually stumbled upon the Pythagorean Theorem, aside from the work of the Greeks. So it wasn't like it was the Greeks alone, but we do take it from Pythagoras. And now, right now, you're kind of angry because you don't like the fact. Oh, I forgot this plus x squared in there, didn't I? You don't like the fact you got these decimals, right? It works out beautiful, doesn't it? We subtract that 156.25 over to the other side, and we'll get a negative 84. Because I like the zero product property. Zero product property is useful to me. Does it factor? Yo. So 8.5 times x and 8.5 times x, you'll add together to get a total of 17x. 8 84 factors of, I guess I think of 21 and 4, and then 12 and 7, huh? So how about 12 and 7? 2x times 12 is 24x. Negative 7 times x is negative 7x. It works. X is 7 over 2, or 3.5, and then x is negative 12. You tell me, which one can I use as a solution for this problem? Negative 12 does not work because that will be a negative length, so therefore x is 3.5. So what's the length of this side? 12. So therefore, area is equal to 1/2 times the base, 12, times the height, 3.5, or 6 times 3.5 equals 21. Why did I do what? All right. You know what? You could get through problem 1 through 8 on your assignment if you want. We're just going to keep going. So tomorrow we'll pick up with more word problems because you love them. This will be all your homework over the course of the next few days. We'll be testing next week already. It's a short unit, just 4, 5, 6 days. What?